That's the mean. And also, let's go back. When we talked about the exponential function, the mean was, the C was 1 over the mean, okay? So f of t equals c e to the negative ct for t greater than 0. So the probability density function would be, it's c e to the negative ct, ct greater than 0, and then c would be 1 over the mean, so 1 over 1,000. So we could also write that as 0.001 e to the negative 0.001 t. Okay, so that's 0.001. Okay. Part B is, what is the median lifetime of these light bulbs? Oh. Okay, so we didn't talk about the median, but the median would be the time, t, such that if you go from, if you say integrate from 0 to t of the density function, you'll get half. Okay, and by default, if you integrate from t to infinity, you'll also get 1/2 as well. Okay, so that's the median time. It's the time t that has that property. So what we do then is, let's just do the first one, I guess. Yeah. Well, wait a minute. Yeah, let's do the first one. Okay, so integral from 0 to t of f of t, that would be this right here, 0.001 e to the negative 0.001 t. So you take the integral, and now it's what? E to the negative 0.001 t. Negative. Okay, so if you take the derivative of that, you have a negative 0.001. There's the 0.001, but you also, there's the negative. That's the way from 0 to t. And that is going to end up being, you put the capital T in first, you get negative e to the 0.001 or negative 0.001 t. And then you subtract and put the 0 in, and when you put the 0 in, you're just going to get 1 plus 1. Okay. And you want that to know when that's 1/2. So basically, that'll happen when that's 1/2. So take logos of both sides. And you get that. And we're supposed to round that. Okay, so you put that in the calculator. I did something wrong. Because oh wait. No, this is correct. I get 693.1. Okay, does that resolve your question?
Yes, it does. Thank you.
Okay. I'm thinking maybe I could have just stopped after telling you what the median was. Maybe like right here. Oh well. But I had to just keep going, didn't I? Yeah, to keep my big mouth going. Okay, any other questions before we get into 9.1? Okay, so let's get into 9.1. Let me bring it up here. So 9.1 is about modeling with differential equations. And differential equations describe a lot of physical phenomena. It's just like the applications are immense. Okay, so a differential equation is an equation that contains an unknown function and one or more of its derivatives. So like, for example, here, this is a differential equation. The unknown function is the y, and here's the derivative, dy dt, and then t is an independent variable. Okay, so it's maybe a little bit different. So you're used to having equations where you have an unknown variable, right? But here, this is an unknown function. Okay, so that's what, and then the independent variable is t, and then you have a dy dt also in the equation somewhere. The order is the highest order derivative that occurs in the equation. So this would be order 1. This is also called, this first one right here is also called an initial value problem because it has this is the initial value. Okay, and this is telling you that y equals 0 when t equals pi. Okay, that's what that initial value is telling you. So y equals 0 when t is pi. Here's the t right here. Okay, and the unknown function, it's usually when we say unknown function, it's usually a function of x, or in this case it's a function of t, or maybe some other variable could be used. Some other letter could be used to denote it. Okay, but this one's y of t. Okay, so this is y of t. Let's look at the other examples from the other homework problems. Here's another one right here. 25y double prime equals negative 9y. So here, this is the second derivative. So this one is order 2. It doesn't have the first derivative, but it has a second derivative right there. And then the unknown function y. It doesn't have any t's in it or whatever, the independent variable. You don't see the independent variable right here, but that you still have an independent variable of t. Okay. And then the third one, this is p is the unknown function. Okay, and it's order 2 or order 1. I'm sorry. Order 1, because this is just the first derivative right here, and then the p appears there and there. Okay, so dp dt, and then t is the independent variable. Okay, so those are just a little bit of the of what's going on. And so now let's get into the exercises. Verify that this function, y equals negative 5t cosine t minus 5t, is a solution of the following initial value problem. Okay, so essentially what that means is if you plug this function in here, and then plug its derivative into here, then the equation, both sides of the equations are equal to each other. So that's what we're after. Okay, so this is, so here's the function again, y equals negative 5t cosine t minus 5t. So because the derivative appears there, we'll just take the derivative of this and then plug it in. So what's the derivative of this? Well, you're going to apply the product rule, right? because you have this quantity times this other one. So the derivative will be the derivative of this part, which is -5, times the other part times the cosine t, plus the derivative of this part, which is negative sine t. So that will cancel that negative out, times 5t. And then minus the derivative of this, which is 5. Okay, so that would be an acceptable thing to put there. So now the left-hand side is equal to t times dy dt. Here's dy dt, so we'll plug that in. Let's switch the order up a little bit. So just putting all this into here. And then distributing the t in. Distribute the t in gives us this, right? And you'll notice that, let's see here. One thing that you'll notice is that this y right here is right there. Okay, so y equals -5t cosine t minus 5t is right there. Okay. And so this part, we'll put in the box there. (5t squared sine t plus y). Okay, so this part's the plus y. So that goes there. And that's equal to the right-hand side. So the right-hand side is this. (5t squared sine t plus y). So that's y plus 5t squared sine t. Okay, so that's pretty much it. So y is a solution of the differential equation. So of the differential equation. So it's a solution of this part. Now this part right here, also y of pi equals what? So to find y of pi, again, you set t equal to pi. So here's our y right here. That's -5 pi. So replace the t's with pi's. Cosine pi minus 5 pi. Let's see, what's cosine pi? That's -1, right? So this becomes 5 pi minus 5 pi, which is 0. So that's 0. And so it satisfies that condition. Okay, any questions or comments about that? Okay, let's move on to the next exercise. 2a, or number 2. So part A was, for what values of k does this function satisfy the differential equation? Okay, so in order to do that, what you need to do is take this and start taking derivatives. So take the first derivative. That's going to be negative sine of kt, but then times the derivative inside, which is just k. And then take another derivative, the second derivative, and the derivative of sine is cosine. So you have another k coming out, so it's negative k squared cosine kt. Okay, now we plug both the second derivative, which is negative k squared cosine kt, into the equation, and plug in the original function into the equation, okay? So this one goes in here, and this one goes in for y double prime. Okay. So cosine of kt. So you have something, so essentially the left-hand side is going to be negative 25k squared cosine t, and the right-hand side is negative 9 cosine kt. So the cosine kt's will cancel out. Then you can divide both sides by negative 25. And then extract square roots. So you have plus or minus 3 over 5. Okay, so your answers would be negative 3/5 and 3/5. Those are the values of k that are going to work. And nothing else, okay? Because really you need this right here, because the cosine kt's just cancel, they just go away. You're not looking for values of t that make this work. It has to work for all values of t. That's what the unknown function has to satisfy. All values of t simultaneously have to work in the equation. Okay, so it's not solving for t, it's solving for y. Okay, the function. Okay, so for part B, for those values of k, which is these two right here, verify that every member of the family of these functions is also a solution. So here you just have cosine kt, but here they're saying if you multiply it by b, it's b cosine t. So like multiply this by anything, any constant, that's also going to be a solution. And as well as multiplying any constant times sine kt for these values of k is also a solution. Okay, and so here they've calculated here we have y equals this, and then they've calculated the first and the second derivatives right there. Okay, so the given differential equation is equivalent to 25 y double prime plus y equals 0, okay? So just taking this to the other side of the equation, right? And then so you get a 0 over here. Okay, so the left-hand side is 25 y double prime plus 9y. Okay, here is y double prime, which is right here. And then, so then here plus 9y. So you just need to put the y in. Like that. Okay, that's 25 a k squared sine t. So they're distributing the 25. So we'll distribute the 9, I guess. 9 a sine of kt. Wait, there's a sine kt right there. Hold on. So we just needed a 9a. Okay, and that's 9. Okay, so we have 9 minus. Okay, hold on. Okay, so let's see here. So this, in this piece, give us this. Okay, so negative 25a k squared plus 9a is this right here, and then times sine kt is all that. Okay, so that and that, so that piece and that piece gives you that. That means you have these other two pieces. Okay, so the cosine kt is right. So basically just take these two and factor a cosine kt out, and you're left with 9. You're left with 9 minus 25 k squared b. And the whole thing is going to be 0. Okay, just like this 0, because k squared is 9 over 25. Okay, so here this is k squared, and that comes into play right there. Okay, so that wiped both those out. Okay, any questions about that or anything else? Okay, let's go to the next exercise. Number 3. Okay, this one is population model right here. And the question is, for what values of the population is it increasing? For what value is it decreasing? And what are the equilibrium solutions? Okay, so we're not interested in solving this, and they're not going to give us solutions. Or maybe we are interested, but the problem is not really asking us to solve it. It's just asking where it's increasing, where it's decreasing, and so on. And it's increasing when the derivative is positive. It's decreasing when the derivative is negative. And equilibrium would be where the derivative is 0. Okay? Now, one thing that is not specified, but or maybe it is specified. No, it's not specified. But the independent variable is t. Okay, you can kind of see that. But really, t greater than or equal to 0 would be appropriate here. Okay, so you want to start when t is greater than or equal to 0. Okay. So the derivative is the product. It's a product of this and this. Okay, and so you're looking for when it's positive. When is a product positive, and when is it? And when is a product negative? And when is a product 0? Okay, so it's a product. Okay, so a product is going to be positive if both of these are positive, and it'll also be positive when both of these are negative, right? And it will be negative when one of these is negative and the other is positive. And it will be 0 when either one of these is 0. Okay, so let's do the 0 first. Okay. Okay, that's going to happen when p is 0 or when 1 minus p over 4100 is 0. So that means 0 is going to be one of the places where it's 0. And the other one will be the solution of this, which is p equals 4100. Okay, so 4100. That'll be the other one. Okay, now for the other ones, what we're going to do, or what I like to do, is do like a number line. So those are the places where it's only these two places where the sign could potentially shift. Here's the two parts of the product. This is always positive. Okay. This scale is p right here. So it's kind of weird because this is not the t. This is not t. This is p. Okay, and you kind of think, oh, well, the p should be no. This is p. Okay, now here, when you're between 0 and 4100, this is actually going to be positive. Okay, because just think, if you put a 0 in, you get 1, and yeah, it's not going to change sign until here, and then it's actually negative over here. So that means that in this interval, you're multiplying a positive times a positive. In this interval, you're multiplying a positive times a negative, so you get negative. Okay? And so that means this is the answer to the first one. Okay? Because that's where dp dt is greater than 0. And here's where dp dt is less than 0, or negative, or decreasing, or where p is decreasing. So the derivative is negative, so p is decreasing. So that's 4100 to infinity. The population would be decreasing. Okay, so that's pretty much the answers to everything that they're asking for. Okay, great. Are there any questions about anything else at this point? Or anything that we've done today? Okay, this looks like a good place to end class.